Tonight, I have the pleasure of sort of emceeing, if you will, for a very interesting discussion, right? A conversation around scaling AI reliability. Um, we have some very interesting people with us here today. We're gonna be talking with also Devon Mitzel from Mistral AI. Sorry, Devon, I'm pretty sure I butchered your last name, but hopefully you'll forgive me for that. Before we kick off and explore the real world lessons from Mistral's AI that Devon will drive us through, I just wanted to start with a few basic housekeeping notes. So we're scheduled for 1 hour today for our webinar. We're gonna, of course, introduce ourselves very briefly. We're gonna tell you a little bit of who we are and what we do, and we're gonna then have the first part of our webinar here which is about Mistral shift to a new monitoring and alerting stack. What prompted it? What the benefits were of this kind of change? And we will also have a discussion on the future of observability in the AI era, because as we all are seeing, uh, yeah, the paradigm's changing, the rules are changing. There's things that used to be very hard or not really possible in practical terms that are now becoming very accessible. The way that we're shipping code and features and maintaining systems and looking at reliability, everything is changing. So it's going to be interesting to dwell on that a little bit. And of course, we're going to have a Q&A session at the end of this, right? So we'll, even though there's quite some things to go through that I think are going to be interesting, there's also going to be interesting questions coming from your end, from our wonderful attendees. And we'll make sure that we leave room for those and try to answer as many as possible. Yeah, so one more thing, everything will be recorded, right? So this webinar is also going to be shared with you afterwards to everybody that registered. So yeah, if you doze off, don't worry, you can catch up on it. That's the beauty of recordings. Yeah, I just wanted to start off then by welcoming our speakers. Maybe we can go to the next slide. So we have a few words about ourselves, right? Maybe Devin, you can start since you're the star of the show here today.
Hey, so I'm Devin. I'm a senior site reliability engineer for Mistral AI. I'm actually currently based out of New York City. If you don't know what Mistral AI is, it's a powerful AI platform for enterprises. We enable organizations to customize and also deploy advanced AI solutions with open models while allowing them to maintain full control over their data and privacy. You may have seen us from some of our open weights models. You may be a customer yourselves of the API or any of our other deployments. Yeah.
Thank you, Devin. And then I also want to invite Sylvain to say a couple of words about himself.
Hey Joe, hi everybody. My name is Sylvain. I'm the head of the AI labs at Rootly. Rootly is an on-call and incident management platform. We are used by, we are helping companies like NVIDIA, LinkedIn, and Mistral to make sure that they are handling their incident efficiently as fast as possible. My focus at Rootly is to explore what AI can bring to the world of reliability. We do this by building a lot of prototypes and open source tools that we share with the community. The AI Labs is sponsored by Anthropic, Google DeepMind, and Google Cloud. And yeah, I'm very excited to be here today and learn more about what Devon built. And we've got a preview, and I gotta say, it looks pretty exciting.
Awesome. Thank you, Sylvain. I'm going to introduce myself as well. I am Giovanni Rago. Nice to see so many of you here with us today or tonight, depending on where you're at. I'm from Checkly. Checkly is a reliability platform that helps developers detect, communicate, and resolve issues so that they can get back to shipping. Of course, as you can imagine, we have quite some AI initiatives in full swing, right? And I myself am at this point using AI daily, right, on a variety of different use cases. So I'm also honored to be able to take part in this conversation. And with that being said, I think we're through with the introductions. And yeah, maybe we can sort of bring in the the catalyst, right, to our current story, right? And Devon, sorry if you go maybe one back. I think we,
Oh,
we might want to just mention, right, who does what, right? That's absolutely right. So, Devon, given that you have had, let's say, the reason recently to bring these tools together, maybe you want to sort of speak to these different aspects.
yeah, sure. So we use both Checkly and Rootly here at Mistral. I'll start with the Checkly part of it. We use it for uptime monitoring. So you can consider these things like your basic sort of ping checks, your basic sort of like DNS checks, curl checks, etc. We also use it for synthetic monitoring. So when we have a new model that launches, or we have a model that we need to essentially run a synthetic test against, send it some sort of input, make sure the output matches what we expect. There's also playwright checks there, which kind of allow us to synthetically test, hey, if you were to go access one of our services and type this thing in, is this the response that you get back? We also use it for alerting. So if one of these synthetic checks or if one of these uptime checks fail, it allows us to kind of send an alert somewhere. We use Rootly for the routing of that. So Checkly is configured to send its alerts over to Rootly, which I'll cover in a little bit. And then we also have traces. You can send your open telemetry traces to Checkly, which then allows you to kind of tie together. When this check fails, here's the open telemetry trace so that you can kind of nail down exactly what failed where. For Rootly, we use it for on-call rotation. So we've got about 8 different teams currently that are on-call rotations. That's about like 50 or so people ish. The last time I checked, more and more seem to get added every day. We also use it for incident response. So when an incident is declared by us, we use Rootly's tooling to be able to say, hey, let's go update the status page. Let's go create a Slack channel, pull everybody together, use things like Incident Commander to be able to help try to manage comms and also like a technical lead. There's also the AI SRE stuff. We do have an integration with Rootly so that you can end up sending prompts over to the Mistral API. And then there's also post-incident learning. This is kind of like the retrospective process. So what went well, what went wrong, what can we do better in the future to kind of prevent it from happening? And then, like I said at the beginning, for Mistral, we are a provider for models, inference. We allow enterprises to essentially own their own data as they're kind of journeying through the AI world.
Thanks, Devin. Thanks for tying it all together there. But this was not always the stack, right?
Yeah.
So I think you have a bit of a story that you can drive us through in terms of where were you before and why did you, let's say, come to this new workflow and this new tool set as well.
Yeah. So four main points here. We had some issues where the previous provider and tooling that we ended up using had some issues with actually performing the detection of failures. At the time, they didn't support playwright checks, so it was a little bit harder for us to kind of test the user stories. We were able to do assertions on the output of the synthetic checks, but what ended up happening is that sometimes the checks ended up getting queued, so they didn't run on like a regular basis. Sometimes the alerts didn't end up firing, which I'll kind of cover in the unreliable paging. There was also some alert noise. Rootly allows you to roll up the checks, roll up the alerts into alert groups. So if there was an incident that was more widespread than just one model being unavailable, it ended up being, 20 pages all at once. So you're a developer trying to work on things and your phone is kind of blowing up the whole time rather than saying, hey, you can roll these things up so it only pages you once, which is really nice. A lot of people call this like alert fatigue or pager fatigue or something. Sometimes the pages just wouldn't really get to us. We didn't have like a phone app like Rootly did, which a lot of developers actually find it really nice to be able to manage their on-call rotations and kind of handle their scheduling and overrides and things like that. So a lot of the alerts would come in through SMS or phone calls. Sometimes I know, for example, like in the US, and especially being in a city, coverage can be a little bit spotty sometimes. So if you miss a phone call, it's oops, right? When instead, when you reconnect, the app will kind of like receive that push notification. I'm also a heavy sleeper. So as well, having a customizable alert sound that sounds like an air raid siren is really helpful. It it also kind of mainly started off in that we had gotten a request as like the SRE team to try to put as many of the synthetic checks that we had inside of Terraform. We're a very heavy Terraform shop. Everything that can go into infrastructure as code does go into infrastructure as code. We ran into a bunch of issues with multiple Terraform providers kind of not having the most, we'll call it stability. Some things that ended up happening were that if you wanted to provision a probe, you had to go create it manually and then import it. And then we also ran into some issues with other providers. And I'm saying Terraform providers themselves. If you've used Terraform, you kind of realize that a lot of the third-party providers that are kind of open source and like not owned by an organization or company, it's really hard to write Terraform providers and have them be very stable. My heart goes out to those champions who decide to maintain their own Terraform providers. Salute you. Also, a lot of resources were just kind of missing here and there. If you can't recreate your stack with infrastructure as code, then it's not infrastructure as code, right? You end up having to recreate things manually a lot. So that kind of loops it all together. We had a bunch of disparate tools kind of floating around. There wasn't a consistent story about how things were configured. And we started looking at alternative providers. There's a lot of other providers out there, and we eventually landed on Checkly and Rootly for solving these problems.
That's awesome, Devin. I just want to sneak in a little question here,
Sure.
right? So how when we look at Checkly, right, we have this big buy-in to monitoring as code, right? Which is something that works very well with AI out of the gate, right? How do you see your developers approaching Terraform, right? Because this is we see it a bit as an ops heavy, perhaps, tool. Is that something that your developers are happy to use to drive even stuff like monitoring and alerting?
Yeah, a lot of our developers have experience with Terraform from previous jobs or even their own curiosity. We try to we try to make things as self-service as possible, but we also understand that not everybody may know Terraform. So we tend to build abstractions away from these things where possible. So, for example, we have like a Checkly module and a Rootly module, and I'll kind of go through the abstraction here in a little bit to where instead of having to go write HCL to provision resources in that way, it's more of like a JSON document that they can essentially edit. And then at that point, it goes and creates the needed resources in both Checkly, Rootly. We also use open source Grafana internally as well. So they all three of them tie together. The I've also used other infrastructure as code tools like Pulumi, which essentially allows you to use like a generic programming language. You can write it in Python, Go, etc. And I think uh, we don't use Pulumi here at Mistral, but I think there are also providers for both Checkly and Rootly, I believe the last time I checked. But to answer the question, most developers actually end up contributing to our own Terraform. We kind of see it as like a shared resource between each other. But there are cases in which like they're not comfortable writing it, but the abstractions we have allow them to mostly write it, or if we need to add something, it's relatively easy.
Awesome. I already can think about a few follow-ups on that. I might come back to this as part of the Q&A later. Don't want to take away too much time.
Yeah.
Devin, what do you think we jump into, what the current solution looks like and how you've been leveraging Checkly and Rootly here?
Yeah, sure. So the way that it had worked before is like, let's say we were to launch a new version of a model. I'll pick an existing model that we launched a few months ago. We ended up launching Mistral Large, the newest version of it. The way that it would have to work before is that you would have to log in to our synthetic check provider. You'd have to click around a bunch and hope that you set the same settings that you did for the other checks. This meant that one check for a model that checked for a certain output, you ask it who is you ask it a question along the lines of like how far away is the earth from the sun or something like that, and that's like a known value, and then you can end up checking to make sure that the output matches that. Well, without it being consistent, we're sort of judging different models by different criteria when there should be consistency. Also, as well, like the consistency around how many failures does it end up taking in order to page somebody. Sometimes it'd be two, sometimes it'd be five. Sometimes it would even be that some models we end up finding that we ended up missing certain checks that we needed on there. So instead, how things kind of work now is we have Terraform as the source of truth for both Checkly and Rootly. And when we deploy new models or we deploy new versions of models, when Terraform runs, it ends up actually picking up what current models are available, configures all the synthetic checks to be consistent, and it then reaches out to Rootly and says, hey, when you get a alert from Checkly that says it has this tag or it has this thing in the title, it knows how to route it between all of the different escalation policies and teams. So at that point, it's way more of an automated process rather than a manual one. As kind of the SRE book says, you need to automate away the toil. And this is kind of one of the ways of actually automating away that toil. So that's the current form of today. I actually have some anonymized HCL that I'm actually going to walk us through that kind of shows how this works inside of Terraform as well. So we're going to get a little heavy into the implementation details.
Let's look at some code.
Cool. So for the first thing, I'm going to go through each block of HCL here and kind of explain what it does. There's a public endpoint that will actually announce like what models are available. So if you have a Mistral API key, this is an endpoint that you can hit to say, hey, what models are available. These models, I'll get into the content of that response later, but essentially you have an API key, you can send it to the models endpoint, it'll tell you what models are there. Then we call a null resource. Both, if you look at the HCL themselves, we have the first keyword, which is like resource or a data block. That second part that's there is essentially saying what provider. So HashiCorp has an HTTP provider that allows you to kind of make arbitrary HTTP calls to different endpoints. It's kind of built for exactly what we're doing here. There's also a null resource, which is kind of a special resource that allows you to perform resources that shouldn't change anything, which sounds a little bit weird, but in this case, we're using it to check the status code and to be like, hey, for some reason, the API key won't have access to the models endpoint, or there's a networking issue, or we've rotated the API key and somebody forgot to go update the secret, right? So we just check to make sure that it's a 200. And then if not, we kind of give a friendly error message. This is kind of where the magic happens in the next step. I wish I could have made this a little bit nicer to look at on the slide because it's a little bit of like Terraform arcane magic that kind of goes on here, but I'll explain what kind of happens here. The first thing is we have a locals block. This is kind of like a variables block where the locals are just locally scoped variables, essentially that you can take variables or the output of other resources or like a data lookup, and you can essentially run functions on it to be able to change its content. So in this case, that first line for models response, we're parsing that JSON and we're parsing it into a Terraform object, which you can, if you're familiar with Python, same thing as a dictionary. If you're familiar with JSON, JavaScript, it's essentially like a JSON object. Then the real true magic happens. Don't focus too much on this, more of like the explanation of it later. So we loop to this response and we actually look at the different capabilities of each model. When you query that endpoint, it will tell you a bunch of information, but it'll also say, here's the model name and here's its capabilities. So for example, the Mistral Medium latest model will do chat completion, while Voxtral Mini Transcribe will do audio. So we end up using this to generate a list that says, hey, here's the different models and their capabilities. So we know, hey, this is what we can test for each model, which then I'll kind of show as we continue. Then we loop through all these different capabilities. This one here is just for the chat completion API. So if a model is marked as having the capability to do chat completion, we create a new Checkly check and we say, hey, it's an API check. We're going to send this JSON body. And then I did have to cut out what we're actually checking here just because it's a little bit some secret sauce that I can't really tell. But what we do is we go through each model that has the completion chat capability, and then we send that JSON input to the endpoint. We then receive it back and make assertions on it. You can think of these assertions as like, when I send this, we get this string back in the response. It has a 200 status code. It should run every 2 minutes. When it fails 3 times in a row, it will send an alert. The important thing to kind of note here as I move into like the rootly configuration are the tags. If you look at the tags that are in here, we put a managed by Terraform tag on there, even though everything in this is managed by Terraform, but it just lets us see, hey, there's a check that exists that's not managed by Terraform. We should go talk to that person and figure out why it's not in Terraform, right? Or it could just be like a testing check we've made as we're playing around with like Playwright or something like that. But the important tag here is completion API. So remember that going forward, in that each block of checks we're making, we're adding tags to say what kind of check it is. I just wanted to pause and see if there was any Q&A before I continue, because then we're going to get into the rootly configuration, or if we want to save that for the end as well.
There's already quite some. I think I see there seem to be about different aspects of this, so I would suggest we keep it at the end, and maybe we
Okay.
can come back to those. So yeah, please feel
Yeah.
free to go ahead, Dan.
Okay, cool. So I'm kind of highlighting here that the important thing is the completion API tag for this one specific type of check. So remember that. We do have a Rootly module that we use to configure Rootly. This is kind of part of that abstraction. So let's say this is like our developer experience API team, right? There are 2 people on this team, Bob and Alice. The grace period for an alert to be responded to is 15 minutes, which then it escalates to like the next rotation. But the important thing here is this services. You can see that there's completion API in here, which you might notice matches the tag that we had previously, but without the underscore. We changed the name here to be spaces and capitalization, just so it looks nice inside of our dashboards and kind of things like that. But I'll kind of show as we continue. So you can see that this team is responsible for the completion API service. There are other services that they're responsible for, but for the sake of this example, I'm just showing one service. So this is kind of a little complex, but I wanted to be true to what we have. So there's a lot of like Terraform magic that's kind of happening here that I'll go through. So Rootly has the concept of an alert route. This means, hey, when an alert comes in from a alert source, which in this case is Checkly, we have other alert sources as well, like our open source Grafana. We're going to create rules that say when this content matches a certain assertion that we have, we send it to this place. We send it to this escalation policy. We send it to this sort of destination. So what we're doing here is we're creating a dynamic Terraform block, which you can kind of think is like Terraform's version of a for statement. So you have for each, which will create the resource multiple times based on the length of something. A dynamic block will create a block inside of a resource multiple times based on some sort of, I don't know, condition or the length of a set or list. So the magic here is specifically in this condition groups, we inspect the tags. So if you go back to the Checkly check that's in here, we're looking at these tags. So here we're saying, hey, when this tag matches, we're going to send it to this service inside of Rootly. So Rootly has these different sort of layers of what constitutes like how people get paged, or that's how I see it, in that there is a service and that service has its own escalation policy, which has its own rotation, then like shadows and things like that. We pick to do it at the higher level service because that allows us to kind of route things a little bit easier on our side. So as you can see, that property field value line is where we kind of take the human readable form of it having space and kind of having proper capitalization, and then kind of like change it to kind of match that tag. So the thing to remember here is that based on what we tag the check in checkly as is where it goes in rootly. So if you wanted to add a new check, all you have to do is make sure that the tag is correct, and then it will make it to the correct team when an alert fires. And then where we kind of are today, we have a lot fewer tools for our observability stack. And also the developers are much happier. They can configure their own monitors, teams, and alerting rules inside of Terraform, which we use Mistral Vibe internally, which is kind of like our CLI coding agent. So we have like documentation for agents.md. So if somebody is like, I need to add a new team, they can open up Mistral Vibe. They can say, I need to add a new team. And then it goes in and it configures the Terraform. They push it up to the repo with a pull request, a bunch of checks run. And that's kind of like one of the value adds of AI here, is that as long as you end up giving the coding agent proper documentation and kind of like how it works, then it can figure out how it performs certain tasks. The models automatically showing up as checks and monitors is a really important thing for us because we're constantly changing and kind of experimenting as we go. And so it's one less thing for developers to have to remember. They can focus more on training models or writing code or the rest of their day-to-day activities rather than saying, hey, I need to, as part of this checklist, go do this thing.
Devin, maybe one question to
Sure.
that, because that's a very interesting point, right? When you set out on this adventure, so to say, of bringing in these new tools, did you already have in mind to begin with that you would want such a workflow like the one that you've mentioned a moment ago in terms of being able to add teams through AI generated Terraform code, or through your abstraction essentially there? Or is this something that you was not really a requirement in the beginning that you realized that you could do at this point as you were testing things out?
I think transparently, I had wanted it to be that way, but I probably in the design doc, I didn't end up writing it that way. I think I kind of ended up writing it as like, hey, it should be self-service. And I come from like a platform engineering background where you write a tool to essentially configure these things. And now with coding agents, you kind of like mostly don't need to write that tool much anymore because everybody's already using a coding agent. So as long as you provide those instructions properly, right, it kind of will build the platform a little bit for you. That might get some disagreement from people, right? But that's kind of what I thought was like, if we make the abstraction simple enough, then at that point, like an LLM can kind of do the heavy lifting for you. And then there's some other things too about AI that and the tooling around this that we can kind of get into later as we sort of talk about the future as well. Um, Hopefully that answers the question. Yeah.
Absolutely. Thank you.
Cool. Um, Lower cognitive load because we like own this interface around the configuration through Terraform abstractions. We can essentially remove that cognitive load like from the developers. Like they don't have to really care about how Terraform works. They just have to be able to read that one, I'll call it JSON document, but it's really like HCL. But if they wanted to do it manually, they could copy and paste that one block and it makes sense. And then if we need to change something across all of our checks or across all of our alert routing or escalation policy, there's one place to change it. And then for the current metrics that are kind of being tracked, you can kind of think of these as like the golden metrics, like the SRE golden metrics, your latency, success rate, the amount of requests, which we track through like Grafana, and then also the correctness of responses. The correctness of the responses is like an important thing to us because like due to the non-deterministic nature of inference and LLMs, we can kind of like make sure that it's close to what we expect. And that's kind of like a powerful thing. And then in addition, there's a bunch of extra things that we can check now with Playwright. Like we can check out the workflows for Lashat. We can check workflows for things inside of AI Studio. We can even use those checks as part of like our CI CD pipeline. So we can test in a staging environment. So then that opens up even more metrics, right? Like page load time, that sort of stuff. So yeah, that's kind of where we are today.
Awesome. Devin, thank you for giving us the story here and also kind of spelling out, what this meant for Mistral. I wanted to just also mention maybe a couple of things about Playwright, right? For the folks who are out there listening who might not know the tool, right? I think it might be a minority at this point. Playwright's been growing in popularity over the last few years quite quickly. Essentially, Playwright is today it is not just a browser automation tool as it started out, but really a full-blown testing framework, right? For essentially automating browser and API flows, right? So you can write end-to-end tests with it and potentially also reuse those same tests as monitors, right? Playwright powers most or the main check types for synthetic monitoring on Checkly. So that's also a way that you can reuse your tests as monitors. But yeah, I think with that being said, we can go on to the second part of our webinar. We have two more to go, I would say, right? So we want to have a little bit of an open conversation, right? And also want to invite Sylvain to join us here and share his thoughts on this. So we want to just have a little bit of a panel discussion here. We won't keep this going for too long so that we make sure we also get to the last part of the webinar, which is of course answering your questions, folks. So feel free to keep them coming. I see already a few both in the Q&A section and the chat. Feel free to post them in the Q&A section if you can, but if they're already in the chat, don't worry, we'll get back to those as well. All right, so to kick things off for our panel here, so I think we have a lot of things that we could talk about, but we've written a few down here, right? And I want to sort of start by asking you, Devin, how on the topic of managing monitoring at scale, right? What are your thoughts, right? Like, where does AI take us there? And I also see, one thing that comes off very often with customers that I'm speaking with is there is a lot of hope in terms of is this new technology what sort of allows us to finally get to the holy grail of these self-healing checks that kind of we don't need to maintain all the time manually and bring up to speed with our rapidly changing applications. So I don't know, Devin, if you have some thoughts about that.
Yeah, I think that managing all of these things is a challenge that has existed since the days of Nagios and Ichinga and the old school tools that we used to have. I think that AI in this case allows us to, as you're using a coding agent to be able to do your day-to-day job, the coding agent understands your code base very well. Hey, you're building a new API endpoint. And when you say, I need to go create new checks, and you point it to like your Terraform repo or your Pulumi repo that has all of your checks defined, it knows like what to actually write the check for because it understands the code base at the same time. I find that that's extremely useful as well because it it allows you to kind of create and manage these checks without forgetting things or without you forgetting to actually monitor these things or for you to remove the monitors if like a functionality is removed, right? There's tooling there for that. I kind of wanted to save the thoughts for like the self-healing and automated remediation until we got to that part because I could talk forever about that, but yeah.
Yeah, I kind of rolled two questions in one here and getting ahead of myself. But yeah, I think what I've been doing for the last few years is essentially very much pushing the pedal on this topic of monitoring as code, right? And this is really speaking to the scale aspect, right? So one thing that we learned at Checkly, which I think was also somehow represented in the story that you told until now, right? is one thing that we realized is that yes, when you actually have a serious setup that you need to maintain for synthetic monitoring, right? Everybody who's actually building and maintaining those monitors and their respective alert channels and so on, and dashboards and all the tool set that is needed for monitoring, that needs to be driven as code, right? That needs to be driven as code. It needs to live in source control, right? Otherwise, just the amount of manual work that goes into maintaining these components is um, essentially forces a choice upon you that you really don't want to make, right? It's either velocity or coverage, right? Are we actually monitoring and shipping features, or are we not shipping features and monitoring, right? So you have to sort of you get forced in a bad place unless you sort of bring this into a developer first workflow, right? The cool thing that we didn't really fully see coming, to be honest, or at least if you ask me, right? I don't know, maybe some smarter people than me at Checkly saw it coming from the beginning, but was also the impact that AI was going to have on this in terms of, again, spinning up these setups. Thing is that once you give a Copilot solution of some sort access to the right amount of context, it can very much generate, as kind of like you were saying before, Devin, right? It can generate a lot of these assets for you, right? And all of a sudden, there is a huge additional advantage to having everything defined as code, right? It might be HCL, right, as in the case for Mistral that you mentioned, but it could really be whatever DSL is being used, or if a vendor has its own CLI, right, that's well documented, comes with enough examples. Or an AI coding agent can do the heavy lifting for us, and that kind of changes our whole workflow.
Yeah, especially in a world of MCP servers, there's like the contexts have an MCP server, or I think there's also DeepWiki. Like Checkly and Rootly, both of their Terraform providers are on there. And then in addition, like the Checkly SDK is on there for like if you're managing it through TypeScript or whatever. Like my own setup that I have here is that like I have a skill, like the new skills thing that like is the current buzz. I have a skill that says like you are a monitoring expert. Here is like when you are working with Checkly or Rootly, the Terraform provider or the SDK, you must go use the DeepWiki MCP server. And then that's how it adds more context of like, this is how you define a check. This is how you end up doing this one task. And it ends up being that if I need to change something, 98% of the time now, I can just pass it off to Mistral Vibe, go get a cup of coffee and come back, and the tests pass and things work fine. It might be every once in a while I got to push it in the right direction, but I think that's a experience everybody has. I think the context around your own code base and sort of the openness of these providers and also the SDKs make it really easy to actually manage these things.
That's pretty great. And if you ask me, a little bit scary perhaps, but yeah, I also wanted to call out, folks, given that we mentioned Playwright in passing, Playwright has an MCP as well available, right? So I think it's really awesome, if you actually want to, write end-to-end tests from scratch, right? It's nuts to see, your agents using Playwright's MCP server to pretty much just do the inspection and, testing things out. And then you can, of course, plug in different things like the Checkly CLI, and this will like try things out on Checkly, deploy them. It's like, it's kind of nuts. That's, I think, when I use all these things in conjunction, this was kind of a wow moment where let's say, a few light bulbs lit up for me on the potential of these coding agents in our world. But I want to sort of move to a bit of a different topic here, but a very much related, right? And I think, yeah, I kind of wonder what your thoughts, Devon and Sylvan as well, are with regards to what this means for alerting, right? And on-call rotations and getting paged, right? So when we have an on-call rotation and we're already going in this direction, what does the future hold? Are we moving to a scenario where agents are actually getting the first page, and then move on from there, or what are your thoughts?
If you want to go first, Sylvan.
Yeah, sure. I can say a bit about this, and then I'd love to learn from you, Devon, and see what you guys have in mind. But what we've seen coming in the industry is a new types of tool that we call AI SREs. And essentially, it's kind of like the next chapter in the story of incident management. Here we spoke about Checkly, like being very efficient at ensuring that we understand when something is not going right, and then Rootly is going to help you to let your people know and manage your incident. But then the rest of the work, which is perhaps maybe the hardest part in some ways, is troubleshooting, right? Understanding what's going wrong and then coming up with a fix. And obviously, as Devon mentioned, we have like this context that's now here and fully available through Protocol Lab MCP to this agent. And so, some companies and users will throw this into a coding agent with some MCP. And if the incident is easy enough, the coding agent might be able to find the bug, come up with a fix, push it through the CI/CD pipeline, and the outage is solved. Now, for more complex incidents, you need a more specialized agentic approach, something that mimics, what SRE do when an incident is here. So when something breaks, generally, the great SRE, they kind of know already the infrastructure. They have this instinct, this knowledge of their infrastructure, and they know which dashboard or which metrics to look. And yeah, this AI SRE kind of learn from all the context that's available to us how the best SRE at a company go about troubleshooting an incident. And these AI SREs are very powerful. We have one at Rootly, and we've seen a lot of customers having early success with it. It's not gonna yet troubleshoot your most complex incidents, but definitely, like a SAFe 2 or SAFe 3, or at the very least help you get started on the hard incident with collection. And Gio, to your point, like I've seen incident where like human was not involved, right? Like went through Checkly, Rootly, then Rootly AI SRE, and the AI SRE solved it automatically. And you could keep sleeping. But yeah, Devon, I'd love to learn what's your take on this. If you have experimented, and also with this in mind, like where do you think the practice of SRE is going?
Yeah, we have been kind of playing around with using like the MCP servers for Rootly, Grafana, and a bunch of different things to kind of like I I think that kind of like the perfect world of this is like an agent ends up getting the page first, looks up all of the different context of like, okay, this page came in through Rootly for unable to add the shopping cart or something, right? I'm going to pick like a generic like sort of response. And then it's able to go look at whatever observability stack that you have, right? It's going to go look at your synthetic checks through Checkly. It's going to go into Grafana and it's going to run a bunch of queries for metrics and logs and traces and stuff like that.